every planet has a major axis and a minor axis. And how oval it is depends on the whatever constant you stick in front of the equation. They could be round. Round is a special form of an oval, or ellipse, excuse me. It's where the two centers have met. So if you had an oval, and then, or at least it's round, that's what you're looking at. Earth's orbit, it turns out, is very, very close to round, like to the second or third character. Now, you did the well experiment, so now you have a guess as the Earth's diameter. He went on to then project. He saw that the moon's shadow fit perfectly at eclipses. And so he just started his timer when the sun touched the moon, took a time when it peaked on the other side, took a time when it was fully out but just still touching. And with that information, he could deduct how far away he was from the moon and how big the moon was, and the same for the sun. Now, at that time, it's hot. At that time, the instruments were literally 40-foot planks that were perfectly leveled, hardwood, and so on. Nobody had any idea how gravity worked. So we're going to do Galileo's experiment, but why don't I try and stick to the script here? One of the things, so we talked about the well and that phenomenon. If those two were right next to each other, spatially, if I just move them next to each other, you find out that this is the 7 degrees, just as this is 7 degrees. Just straight geometry, right? Mm-hmm. And that's gave him the circumference of the Earth. And then he used that information to get distance and circumference for the sun and the moon. And Big Bang, the first or second chapter, covers that in really, really great detail. But there was one way they could try to measure how far the stars were. Let's pick a star. And here's the Earth. Well, and let's just, for fun, put the sun there. All of these are completely non-representational. Okay, so here's our star. Our wonderful star. We're sitting on Earth and we take a reading, and we also notice that we take the reading at exactly midnight. The sun is directly behind me. And they take a reading. And the next day, excuse me, the Earth has its own orbit, right? And I'm exaggerating that quite a bit. But it has its own orbit. So, whoops, drew it wrong. Sorry. So you take that here, that reading here, and that's going to be at a, actually I think those are at the equinoxes. Yes. Oh, help me out here. My brain is just not working today. If you take another reading from here, although that's grossly exaggerated, you can find out what this angle is by doing that for close stars. And then you look at another star, it didn't move at all. Well, what did that tell you? It was just way over there, and that's it. But Tycho Brahe collected information about the wanderers and about stars and kept voluminous records, which his protege who disagreed on theories with him tried to use to prove that he was wrong in his statement. Anyway, but eventually they made it into Kepler's hands, and Kepler came up with his equation. So we have Tycho Brahe, the guy. This is the memory trick. Silver nose. And that's my handwriting. Then we have his assistant, and I think his last name was Russell. I may be wrong. Then we have Kepler, who came up with Kepler's laws, which means that every planet follows an ellipse, and that if you were to take one spot and follow it around to another spot on that ellipse by looking at fixed stars, like the North Star right now, although it's not really fixed. And he could come up with mathematical formula that told you that they could make predictions. And that's what the whole thing is about. Science is about trying to come up with methods with methods or principles that will apply to the natural world. So he came out with those laws which related to the area covered in time. Whoops, I should have put the... although ellipses have a major and minor axis, they... oh, that's my third son. I'll have to go back and look. But if you do that for any slice of time that's the same, the area is the same. Then telescopes were invented by a Dutch man, really perfected or improved upon by our next friend, this is terrible. I'm losing my... So Galileo then came out with support for the Copernicus, who actually has a totally different real name, but that's what we anglicized it to. And his book, which was something about the celestial spheres. This got him into a lot of trouble. He did some experiments that you heard about, right?